Hello YouTube, welcome to this video. So in this video, last video we're talking about theory tests, which is over here, which means we have pretty much completed what we want to do with the IXml library loader, except that for the dwsim XML library loader class, we did not do anything. Okay, we used the brute force method of loading in our XML libraries so that it makes it available. Okay, so this IXml library loader has been fully tested, at least to the extent that it was planned here. So that's good. Okay, so now we want to move on to other things, right? So like IXmlComponentList, okay, and maybe plan out some other classes as well. So it's obviously, it's a good idea to actually start planning out all your classes before you're writing the first line of code. Yeah, so that most of your work will be done in the mind map, rather than you start writing your classes and interfaces and then you find something pretty off along the way. Plan them out here first. Okay, so yes, what do we have here? All right, so I'll just show you some of the thought processes behind planning one or two classes or interfaces. Okay, and then I'll show you the completed version of what I've done with the mind map. Okay, so what do we want at the end of the day for these IXml libraries? We want to put in a fluid type either as a string or enumerated variable. We want to return some kind of desired properties, again using a string or enumerated variable. Supply fluid conditions like temperature and pressure, okay, as doubles. Okay, temperature or pressure doubles. Okay, so, and then of course we can specify a desired library. And then the outputs, what are the outputs? I want a desired quantity list. It will be an IXenumerable of engineering units. Okay, for example, the ideal gas heat capacity constants and the viscosity constants. Okay, I don't exactly know how these actually work, but we can actually take a look over here in the dwsim databases. dwsim. Okay, there's a class called dwsim. dwsim. Yeah, this is where we have it. And then we can actually look at what's over here to see what units there are. Okay, unfortunately there are no units being supplied here, which is not the most convenient. And you can see that for this XML load, there's a case structure. Okay, you see select case. This is a lot of things to do. It's not say a very friendly way of doing it, but it's good that it's easy to understand, but the code will get messy the longer this list gets, and it's not very easy to extend the functionality. So this in a way, unless your list is fixed, your XML list is fixed, this kind of violates the open close principle. Okay, but what's useful here is that you can see what the CS actually stands for. CS eccentric factor is a child-seeded eccentricity factor. CS solubility parameter is child-seeded solubility parameter, so on and so forth. Okay, eccentric factor and Z racket not really explained here. Dipole moment is over here, and let's take a look at where this dipole moment is. Okay, dipole. Yes, there's a dipole moment right here. Okay, for nitrogen is 0, or first both of them are the same molecule, same atom. Okay, DIPR vapor constant A, no units here. We'll have to do some digging to see what units these are more or less later. Okay, but what am I saying here? Yeah, we can actually look in the dwsim source code to figure out what units these are before we start. Okay, because the engineering units package actually requires you to specify the units. Okay, I'm not sure whether you can make a ideal gas heat capacity constant kind of a unit, but we'll see. Okay, List of components are enumerable or string. That's why we have this IXmlComponentList. That's what it's supposed to do. IXmlComponentList is supposed to supply a list of components. List of available properties, enumerable or string. That one's also in a sense straightforward because, okay, pardon me. Yeah, so assuming we have, for this list of available properties, assuming we have all the things that like for example, we want to print out all the XML components within water, we just take a look at what the name of each XML component is, and then we can just return it as a string. Okay, so this is the list of available properties. We can actually make another class to take care of this. List of available XML libraries, also we can make another class, but this is the most important thing, right? Desired quantity list. Okay, which interface or class will take care of making this desired quantity list? It will be this IXmlReader. IXmlReader will have this input, which you can specify the fluid type, and then you can get the desired quantity list. Okay, outputs will be enumerable of engineering unit quantities. Dependencies is this NuGet package. So there's of course one more thing I forgot, which is tests. Yeah, tests. Okay, there should always be 5, at least as far as possible, 5 branches for every new interface you make: input, output, dependencies, implementations, and tests. So this will give you a standard template of getting this mind map going. Alright, so let's say for this IXmlReader, we'll have a fluid type. You are supposed to supply a fluid type. What is your component? Okay, so this should be a string. Of course, place your types here so that it will be easier for you to code first. So this desired quantity list will be enumerable of, okay, actually no, this one should just be a string. This one should just be a string. Okay, or you can make it enumerable of over also, but nah, I don't want that. Okay, this output will be enumerable of engineering units quantities. Okay, so what's going on over here? Okay, so for example, let's say we just want ideal gas heat capacity, gas heat capacity constants. So it's constants A all the way to E. Alright, so the first thing first is that, yeah, we know how to extract ideal gas capacity A, B, C, D, E. There's no problem there. We already wrote some code to get boiling point, so getting the ideal gas heat capacity constant A, B, C, D, E should not be an issue. Okay, of course you have to code it in manually and all that, but that's fine. Okay, the only problem is that over here there are no units at all. Okay, all these things are unitless. Okay, you can of course get them, and the moment you get them out, you can convert them into a double, which is good. You do want to convert them to a double, but then there's another bit of code that should take care of the converting this to the engineering units quantities that we are talking about. So how's the thought process go? Maybe I'll have IXmlReader version 1. Okay, so that's for example. Alright, so I want to make an implementation of IXmlReader version 1. Okay, let's describe how it will work, how it works. Okay, so first step is that it will take in fluid type. Okay, get a class returns the X document or X element. So this is how I do the thinking first. Second is, right, once you have the with this X element of the fluid, okay, start filtering out. Okay, you start filtering out the packages, right? Start filtering out the quantities required, e.g. ideal gas heat capacity. And then 3, we just start building a list of quantities. Okay, return, okay, it will be a list of double. This will be a list of double. Okay, and then fourth job is to convert the quantity list into what? Engineering units. So this is roughly how the thing will work. 1, 2, and 3 takes in the fluid type, returns the X document or X element. Alright. So how will this thing work? Okay, probably you have the dependency. Dependency is here. Okay. Dependencies. So I will need a class to help me get this X document, right? So this will be done primarily by this IXml library loader. Okay, so I can just move these classes right to the right. These interfaces to the right. Okay. Of course, over here, this IXml reader actually needs a library as well. Alright, so you should input library. Which library to use? Okay, so well, which library to use? Okay, maybe the way we can actually choose which library. This one maybe we'll do it later. We'll just assume that we are using the dwsim library first for simplicity. We don't want to complicate things too early, too quickly. Okay, so first we're taking a fluid type, the class that returns the X document or X element. Maybe I just want to be more specific here. Class that returns X element with all the fluid data. Okay. Oh dear, my Minder just crashed. Okay, let me open Minder again. Segmentation fault. Okay. So okay. So take in fluid type as string. Then get X elements of fluid properties. Remember, we were actually able to, for example, if we supplied nitrogen, we are actually able to return all of this data as an X element, right? That's no problem. That one we have done before. Okay, so we get the X element of the fluid properties first. Okay, so yeah, so where do we do that? Maybe, yeah, in these dependencies we can put down here. Okay, X IX element I component XML component, something like that. XML component IXml component. So this job will be taken care of by this interface. Okay, so how do we do this? We make another interface called because we want to follow single responsibility principle, so we don't give too much work to do for one interface. So this will be IXml component. Okay, and I'll do an X to make sure that this component here is actually taking care of this job, and this component's job is to take in a fluid type, which is a string. Okay, so I put inputs, outputs, dependencies, implementations, and tests. Okay, first input will be fluid type, which is a string. Okay, the output will be what? X element of fluid property. Okay, this is an X element. So this returns the raw X element file. Dependencies, okay, not, maybe I can do iDisposable. Okay, no iDisposable there. Implementations, and of course we also need to do the testing right here. We'll do that maybe towards the last part once we figure out how this code is supposed to work, what is it supposed to do. Okay, implementations. Okay, how is this thing supposed to be implemented? Maybe well, for these component loaders, it's kind of different from different type of libraries. So maybe I have a dwsim component XML. So this is how I do it. Okay, so tests right here will be load XML manually, compare with object loaded using IXml component. Okay, look, okay, I'll say load X element just to be careful. Load X element manually, compared with object loaded using IXml component. Okay, object is X element. Alright, so this is how I usually like to plan out. And then of course dwsim component XML, what is it supposed to do? How it works. Okay, I'll put the step 1 here. Okay, load X document of dwsim library. Okay, so that's what the get X document here is supposed to do. Okay, we have a XML library loader, get X document, so that's what it's supposed to do. Secondly is supply a string and return X element. So this class's job is pretty simple. Okay, load the X document and then supply the string and return the X element here. Okay, so over here I can just put the dependencies here, and it's quite obvious that this should be dependent on IXml library loader, because that's what we are going to use to load our X documents. Okay, so we can of course change the way that the mind map is structured to make it so-called fit better, like so. So then the dependencies can be as such. So IXml library loader, I can put it here. Okay, see? So like this, we start to have a network of classes. We know how it starts to depend on each other. You can see it's getting a little bit messy, and then we also don't want to make it too messy as well. The more messy it is, the more complete. The good thing about mind maps is that, you know, the more messy your mind map is, the more you know that, you know, your code's getting a little bit too complicated. Yeah, so but you know, that's something we can like sort out now in the mind map, rather than, you know, code put all that hard work into the code, and then after that figure out that you have to reorganize things, and that when you want to change something, it's so very hard to change. Okay, so this is how I plan out two classes here, like the two interfaces with their classes right here, IXmlReader and IXmlComponent. Now this is the thought process. In reality, I did not plan it exactly like that. I have actually already did most of the work here. So this is just a demo for YouTube to help you understand the thought process behind using the mind map first. Then we start planning out the way classes are structured. And once we, of course, we will need to plan the tests here as well. Like what test should this be? Okay, I want to extract ideal gas heat capacity constants of water, extract viscosity of water, viscosity constants. Okay, so after that we can use theory tests to do this. Maybe nitrogen, air. I don't know whether there's air here. Air. No, we don't have air. Okay, So we don't have air, maybe benzene, whatever, water, nitrogen, benzene. Benzene is one of the first organic compounds that comes to mind. It's a classic case of organic chemistry. But anyway, yeah, so we have all these tests we can plan out. So once we have the test planned out, once we have the implementations, dependencies planned out, we can start writing our class, and it will be very, very structured. Okay, the way the code is will be very structured, very loosely coupled. Of course, strictly speaking, some of my code is a little bit more tightly coupled than what this mindmap suggests, but you know, as far as possible, the ability to have it loosely coupled is already here. Okay, so that's how I like to look at this. Plan out the mindmaps first, then we code later on. Okay, so if you have remember, dependencies should only be for the concrete classes, and each of these dependencies should be strictly speaking on, you should be dependent on an interface rather than implementation. Okay, rather than a concrete class. So that will obey the dependency inversion principle. As far as possible, yeah, you can obey the dependency inversion principle. So that's something nice. Okay, we can of course rearrange this mindmaps to make it look a bit nicer, like so. Right, so that's an aesthetic thing, but you don't want too many arrows flying all over the place. Okay, so let me show you. Okay, let me show you now what my mind map looks like, because this was a YouTube demo. Okay, so let me exit this, git stash, because I want to abort all my changes. So let's git check out mind map. Okay, and over here is where I actually store all my latest mind maps. Okay, netcore. Let's go to readme, and we'll do the minder, IXmlLibraryMinder. Okay, I already have it open here. So this is how my class actually looks like. A little more complicated, lots of tests, lots of classes going all over the place. Right here, I have the IXmlLibraryReader. Okay, this will be, the first implementation will be the dwsim XML reader. Okay, so this IXml reader depends solely on the dwsim library. Okay, what is this dwsim library supposed to do? Take a IXml library class from IXmlLibrarySelector. So this IXml library class object gets passed into IXmlQuantityRetrieval, which passes the desired quantities back as a IEnumerable type of double or string. So over here there's this library selection thingy going on here, because there are many different libraries. Okay, there are many different libraries that we can have, so we have to select the correct library. So there's chemsep, there's dwsim, so this part takes care of library selection. So the next step is to, once we select the library, we need to take the correct quantities. So this is step 2. Okay, and it passes back an IEnumerable of double or string. So here is this IXmlQuantityRetrieval interface. Okay, third part will be unit conversion. Okay, the unit conversion will take this IEnumerable stuff and then pass back the what do you call that? Pass back the let's see. Yeah, it will pass back the quantities as engineering units. So at least from a very high conceptual level, this is how it is done. Okay, how I actually do it also, yeah, it's a we'll figure that out as we go. But let me show you what's going on here. Okay, IXmlQuantityRetrieval, what does it do? It takes in the concrete class IXmlLibraryLoader. So it takes in this object, it takes in an IXmlLibraryLoader object, right, based on the library you selected. Okay, let's see, over here, takes in the IXmlLibraryLoader, takes in the desired quantity desired quantity type. Okay, and the library, the library type will be sort of decided via dependency injection mechanism, meaning to say depending on which implementation you take, the library is already selected for you. For example, dwsim IXmlQuantityRetrieval will only deal with dwsim libraries, nothing else. Okay, and now of course load IXmlPropertyList method. Okay, so this thing is supposed to give you back a list of XML properties. Okay, so this is the IXmlPropertyList, which will fulfill this job. Okay, and then it will output the IEnumerable of double or string of these quantities, like the heat capacity thing. And dependencies here are disposable, so I'll deal with that later. Okay, this thing is, it will do the job. It's like it will do the job of the IXml component thingy, which I just call it quantity retrieval in this case of the mind map. Implementations will be dwsim XML quantity retrieval. The class will first take the desired property type by the user, and then of course compare it to the available property types. Alright, so what are the property types? Okay, I actually have to check against a list. Okay, so I have this list that actually will take in, it will take in what do you call that? It's a bit convoluted and complicated, but yeah, this interface here will take in the IXml library, and then it will return to you IEnumerable of string. Okay, what are the available properties within this library? Okay, so the implementation, the only one I have now is dwsim IXmlPropertyList, which loads the dwsim XML library, returns a list of strings showing what properties are available. Okay, so let's moving on. I mean, yeah, this is how it's this is what this job of this class is supposed to do. Okay, of course, if you take a look here, okay, if you take a look here at dwsim thermodynamics, okay, vim dwsim XML. If you take a look here, you'll see that if I just want ideal gas heat capacity, I'll have 5 constants, A, B, C, D, and E, right? Do I then want the user to ask for ideal gas heat capacity constant A, ideal gas heat capacity constant B, C, D, and E? Okay, answer is no. Okay, I just want the user to ask, okay, I want ideal gas heat capacity, and then I will have a list of the constants A to E. At least that makes more sense, because as the end user, I won't know what kind of data is available for ideal gas heat capacity right here. Okay, I won't know. So the best way is to just say I want the ideal gas heat capacity or heat capacity, and then I'll just supply all these constants for you, right? So likewise, vapor pressure, I do not want to know whether it's vapor pressure A, B, C, D, and E. I just want to know, okay, I want vapor pressure, please supply me with these constants. Then I can give you all the data pertaining to vapor pressure. Charles Cedar also, SRK, Peng, Robinson, Z, Racket, critical stuff, I can also do that. Okay, I can group all these under what do you call that? I can group all these under I can group this under one category of things. So what is this category of things here? Yeah, I will call this the IXmlHumanReadablePropertyList, because I don't want the guy at the end of the day to specifically ask for liquid viscosity constant B. Rather, I'd say, hey, please supply me a list. I want to have liquid viscosity. Okay, if I have liquid viscosity, then I'll supply you these 5 constants for you. No problem. Okay, or boiling point, enthalpy of vaporization, etc., etc. So these are the things that I want to think about for making it like at least user friendly, somewhat user friendly. That at the end of the day, I don't need to ask for A, B, C, D, and E. I just want heat capacity. Then I'll have these 5 constants come out. Right. So Yeah. So that's what this list here is supposed to do. Okay. Inputs will be library type via dependency injection. So yeah, so we select an input type. The output will be IXmlLibReader of properties. For example, ideal gas heat capacity. So at least these things are a little bit more easier for the end user to kind of use, right? So that's what we want to do. We want to provide a property list that actually does all these things. Okay, that actually encompasses. Okay, let's say vapor pressure, entropy, enthalpy of formation. Okay, so from the end user, yeah, what's the most intuitive way of accessing these properties? All right, critical temperature, pressure, and volume. Those will be also, yeah, those are quite, I mean, easy. If I want these critical temperature, I will ask for critical temperature. But for things like this, vapor pressure constants, ideal gas heat capacity constants, viscosity constants, not that straightforward. Okay. So these are things I will tend to want to group under something. So that's what this human readable property list is for. All right. So the thing is that based on this human readable property list, I will divide them out into like cases, and then I'll say, okay, if the case is this, let's say I have ideal gas heat capacity. Then how will I yeah, if I have ideal gas heat capacity, how will I load it? All right. Yeah, so this is what this class is here to do. You load in the string, okay, and then it will compare against a human readable property list. And based on this human readable property list, I will then start to populate your chosen quantities back to you using some sort of case structure or something else. Okay, comments for this only works for the dwsim library, because this is the first iteration. Probably the first round of code writing will not be that good. Okay, won't be that good. We can always improve on it as we go along. But code doesn't have to be perfect. It has to be neat but not perfect. Okay, so this part does those jobs, and then this class here, well, I should maybe, yeah, and then the rest of it I will just put it into the quantity retrieval code here. I'll see how long this code is. If I need to break it up some more, I'll break it up later. Okay, so what are the tests for this IXml quantity retrieval? Okay, compare heat capacity of water using manual code versus the function calls, meaning to say versus the implementations. So maybe I'll call this implementations here. Okay, maybe I'll do that later. Okay, then it says here, compare liquid viscosity of constant of nitrogen using manual or hard code, and make my own IXmlLibReader list versus the function call. Okay, so I will do a for each comparison kind of a thing here. So that's what we do. Okay, so this is what this IXml quantity retrieval is supposed to do. You supply all this information, it will give you back the IXmlLibReader of string or double. Then after that, come back here. Once you have this string or double list, then I will come back here and say, alright, I need to start converting the units. So what are the inputs here? IXmlLibReader of double, whatever quantity this is, you need to supply a quantity type, and then of course you need to specify what's the library. Okay, again I select which library through dependency injection. Alright, through selecting which implementation of this interface I'm having. Okay, then the output will be IXmlLibReader of engineering units. Okay, so my first implementation is going to be very tightly coupled. It's not the best, but it will do what it needs to do. Okay, how it works, it will take in the quantity type, select a unit conversion method based on the case structure or something like that. Then each method will then convert units in a specific manner. Okay, Okay, for example, ideal gas heat capacity. For ideal gas heat capacity, a new list of engineering units will be instantiated and returned. Okay, so the unit converter here will then take in some things. Yeah, for example, we selected IXmlHumanReadablePropertyList. Okay, maybe we can make this thing dependent on this interface so that we can have a human readable property list right there. Yeah, so that's what we can make it do. Okay, so sort of do that. Okay, then after that, based on that, we can actually do the unit conversion. Okay, so we have a specific case structure. Alright, so yeah, so that's how my mind map planning kind of goes. Again, it's not perfect mind map, it cannot be perfect. I need to start going into nitty-gritty of code to see whether this mind map can be like practically implemented. Now as you scroll out, you see there are so many implementations and classes. Okay, you don't want anything of this to be too messy. You can see it actually looks like a school of airplanes or fish. But maybe 12 nodes per mind map is good. You don't want to overcrowd your mind map. If not, put it in a different project. Yeah, so that's just some organization and structure for you. Okay, this way your code is very, very nicely packaged, very modular, very loosely coupled, or at least it gives it the capability to be loosely coupled. Whether it's loosely coupled or not, it's still up to you how you want to write the code. But that's how I do it. Okay, so the thing is that once I plan out things with the mind map, okay, you can go and study this more in your own time. I won't probably not maybe I should go through in detail. But I've gone through in detail some of these things already. So once these things are done, once the mind map is planned as much as possible, then go on to writing the code. Right? They write the code according to the mind map. So so let's see. So what's the next step? Okay, or rather let's take a look at how the other parts work. Okay, so we have explored the IXml reader so-called branch of dependencies. So the IXml reader, you kind of know what it does. It's supposed to be there to return to you the IXml units and everything based on a quantity retrieval interface. And then this thing will have some complicated case structure. You'll do stuff inside it'll do stuff inside that it needs to do to return you all the data. Okay, this unit converter here will convert the units that are retrieved by the quantity retrieval class. Okay, why do I break it up? It's so that in case you just want the IEnumerable of doubles, you can do that. They won't be so tightly coupled that I can't access the doubles by themselves. Okay, so that's it. Okay, for this part, IXml quantity retrieval, the human readable property list, and IXml property list. Okay, this one is quite straightforward what it does. Okay, then of course over here for these implementations, I also want to return a list of available properties, IEnumerable or string. So I will have my IXml property list right here, and that will actually give you a list of all the properties available. And maybe I will want this human readable property list to also come out here. Okay, to fulfill this job of giving you a list of available properties. Okay, so that is something I might want to do later. So that's what this IXml property list is supposed to do. Okay. In fact, come to think about it, this thing here is very similar. It's very similar to this IXmlPropertyList right here. Okay, in fact, yeah. But anyway, their jobs are different, so I don't want to just conflate both of them together and put them under the different implementations of the same type. Okay, so maybe we'll skip that. Okay, so we have we have discussed IXmlPropertyList, we have discussed IXmlReader. Next thing is to do the IXmlComponentList. Okay, I'll just move this up here to make it slightly neater. Again, yeah, I don't know whether that helped a lot, but okay, IXmlComponentList. Okay, what does it do? You take in a desired library and return you a list of components. So, so the desired library, you kind of select it through dependency injection. Which one do you want? So first thing is the dwsim XML component list. Okay, so I will what is this? The XML component list using child nodes method. Okay, this one is if you use XML document. You don't have to use XML document. Alright, but okay, maybe this is one of the ways we can do it, but I'm not going to use it that way. Not necessarily. Okay, I will need the IXml library loader, however. Okay, the library loader here will actually take in the, I will have this dwsim brute force class so that I can get my X document. So maybe I will, yeah, the way I describe the method here is not too good. Maybe I will, the way I'll do it is, how it works. That's in future mind mapping. So I'm still kind of formulating this mind mapping technique as I'm going on to see what are some best practices. Then I'll try to follow them as much as possible. Okay, so here's the IXml library loader. It will be one of the dependencies of the dwsim XML component list. IXmlLibrarySelector. Why do I need that? Okay, I don't know. Okay, but actually all I need is this IXml library loader. I will load in a random component, for example, like water. Load in a random component like water, and then after that I will just what do you call that? After doing that, I will then I will load the components that are available there. Okay, as a string. Okay, once that is done, I can load the component list here and return it over here. Okay, return a list of components. Okay, wait a minute, I don't need. Okay, anyway, the IXml component list is supposed to return you all the components that are available there. So I do not need a library selector here, so to speak. Should I? Okay, never mind. Oh right, I'm probably confusing myself. Here's this dwsim XML component list. It's not referring to the dwsim XML itself. It's actually referring to the entire library. Okay, I mean this whole thing is called the dwsim XML library, so maybe using dwsim as a name may not be useful. I'll just call this XML component list version 1. I'll call this the version 1. Okay, so you take in the desired library, it will churn out the list of components that are expected. Okay, so I'll have a library selector right here. This library selector will show you what available libraries there are, and based on those available libraries, I will then return the IXml library loader. Once the IXml library loader is done, I can start to take out the classes that are there. Okay, I can start to take out the classes that are there, or rather take out the XML documents that are there, and then see what we can do later. Okay, so over here again we'll have a case structure. a case structure of, or rather a way of, you know, based on the libraries. For example, this is the dwsim library. I can also open, okay, I can also open the ChemSep library. Okay, the ChemSep library is different from the dwsim library. As you can see here, compounds here is library ChemSep v8.00 pure component data. Okay, it's 95,000 lines long. So you can see the way the components are being stored is pretty different. See, there's it will be here under compound ID, and then you will kind of use attributes here instead of yeah, this one is a very attribute heavy library, as you can see here. Okay, so instead of using the values of these, we have attributes, and it's much nicer here. They actually have units so that it doesn't confuse you. Okay, and they have a maximum and minimum temperature. This is a very much nicer library to use, in my opinion. Oh, look at this, they even have thermal conductivity. Huh. So there's a lot of useful information here we can use for later. Okay, look at this argon, and then we have all these liquid properties. So the way that this XML library is formatted is different from the dwsim one. So we have to use slightly different methods in order to obtain the name, obtain the value of all of these things. Right? So yeah, look at this compressibility factor. It's unitless. Oh yeah, it's very nice. They put units here. I love it. This is a much nicer library. Okay. Yeah, I'm a lot more in favor of ChemSep than the other library, which was manually constructed. So this is very, very good. Okay, dipole moment and everything. So we'll probably make another class that can actually absorb in all this data. Alright. And using Vim is good because this file is huge. Okay, this file is huge. And navigating through this file is no easy task, as you can see. And this is only one of 2 XML files. Okay, but maybe the ChemSep thing we can actually load later. Okay, this polypropylene glycol. Okay, Control F to do a page forward. Okay, so you can see that a lot of properties here. Very useful data. Again. Okay, so we'll create we'll create nut tree using Q. Yeah, but yeah, that's what we have. So maybe first thing first. Yeah, so this is how I planned out my module, all its interface and classes. Okay, I will not have it perfect the first time round. I think if you want to try aiming for perfect, so-called list perfect way of arranging every single interface, you'll never actually get started coding. So that's not good. Okay, you just get something like maybe 80%, 70% of the way there, start coding, and then if the code gets messy, then refactor. Okay, split it up into more interfaces and classes. Okay, so that it's neat later on. So the nice thing of course is that why are we splitting all this up into various interfaces is to make get all the components loosely coupled and modular, so that if we need to make changes to this code, which we probably will, alright, if we need to make changes, it is actually doable, rather than looking through 2,000 line long class code in a tightly coupled manner, and changing one piece of code can actually just break everything, so that's not good. Okay, so if we want, we can actually rearrange the ways these things are coupled, because they're coupled so loosely. So that's the advantage of doing things this interface way. Okay, so this is like one version of the mind map. It can be subject to change after we code. That's fine. So what's the next step? Wow, I've been talking for almost an hour. Okay, what's the next step? Next step is look at this IXmlComponentList. Okay, IXmlComponentList. Then the next thing is that we want to make a new feature branch. okay, and start doing the methods that are inside this IXml component list, such as having this IXmlLibrarySelector, IXmlLibraryList. Okay, this list is, if you want to select your libraries, you need to have a list to select from. So IXmlLibrarySelector, you put in the string of libraries, you put in the string of the library you want, and then you select that. Okay, IXmlLibraryList, what this does is that it will couple together. It will be a list of tuples, tuples, string and IXML library loader. It will be the string and then the IXML library, okay. And then what it will do, is that it will load all the implementations of IXML library loader. Okay, load all the libraries, and then it will package them into tuples. Okay, into tuples with the string, and then it will construct fresh library objects. Okay, so that's all. That is the current version of the mind map. Again, we'll change it as we go along. Alright, hopefully this is helpful to see a thought process of how one can actually think about coding interfaces and classes before even writing the first line of code. Okay, so next step will be, I want to look at this branch called IXmlComponentList. So I want to be able to, based on a string, go and see what component list is available, what component lists are available for each library. Okay, that is the next step. Okay, so I'm going to stop recording. It's almost 50 minutes. I'll see you guys next time. Bye bye.